Hi, it's me, Dr. Prasad Puthiyillam. In this class, I am explaining about the laboratory, inorganic laboratory, determination of iron and calcium mixture, or determination of iron and nickel in a mixture. So, both it can be done, it can be explained in a single video. That's why I made it like that. It is a mixture of iron and nickel or a mixture of iron and calcium. So a uniform and homogeneous mixture of metals, two or more metals, including non-metals, we call them as alloys. So if such alloys are there, if you can dissolve it in a particular acid or anyhow manner, if you dissolve the alloys, we are getting the corresponding metal ions. Or we can prepare these mixtures in our laboratory using these non-solutions or non-chemicals. It can be prepared for to understand how it can be estimated. Say example, the iron solution, it can be prepared with ferrous ammonium sulfate, FAS, or we call it as more salt, which is FeSO4, NH4 twice SO4, 6H2O. A nickel solution can be prepared with a nickel ammonium sulfate, NiSO4, NH4 twice SO4. Calcium can be prepared from calcium sulfate. Therefore, a mixture of iron and nickel can prepare from FAS and nickel ammonium sulfate. A mixture of iron and calcium can be prepared by mixing ferrous ammonium sulfate and non amount of calcium sulfate. Therefore, a combined method I'm giving here, in from which iron can be estimated by gravimetric method. Say if ferrous, if it is there, whether we prepare from alloy or we prepare separately with the ferrous ammonium sulfate, it's on oxidation, it will be converted into ferric Fe3 plus, which on presence of ammonium hydroxide and ammonium chloride will be converted into ferric hydroxide, which on heating will precipitate. A ferric hydroxide itself is a precipitate. Further heating, it will be converted into Fe2O3. That Fe2O3 we can weigh gravimetrically, that its weight we can measure, and we can find out how much Fe is present from that. The nickel and calcium will remain in solution as a nickel 2 plus ion or calcium 2 plus ion. It may be in a complex state with the ammonia solution also. Therefore, nickel and calcium, if it is there, it will be there in the nickel 2 plus or Ca2 plus state. So if we prepare 25 ml or 50 ml of the solution containing the Fe2 plus, which is prepared, the solution were prepared, this iron solution or nickel solution or calcium solution, we prepare in 250 ml. You should, say I'm taking example of 250 ml. From that, if you prepare 25 ml or we take out 25 ml for calculating the amount of iron, or we can take 50 ml for calculating the amount of iron. Okay, so it should be should remember how much we preparing, how much we are taking. To that, we have to mix it with the concentrated nitric acid HNO3, so that Fe2 plus will be converted into Fe3 plus. Approximately 1 gram ammonium chloride, it is added, diluted with water, then heated into that hot solution. 1 to 1 ammonia solution is added dropwise till the Fe3 plus completely precipitate as FeOH thrice, and the precipitation completion also one need to check. The obtained precipitate is filtered using Wattman filter paper. The filtrate or the solution, after removing the precipitate or residue, whatever remaining solution, the filtrate, it is kept aside for the estimation of nickel if it is iron nickel mixture, or estimation of calcium if it is iron calcium mixture. So when we add ammonium hydroxide or ammonium chloride to that, ammonium hydroxide ammonium chloride, it is converted into FeOH thrice is a precipitate. So this precipitate, it is the Wattman filter paper containing the precipitate, it is taken, we call it as the residue. It is taken in a previously weighed silica crucible, and it is ignited. Okay, so it will be converted into Fe2O3. FeOH thrice will be converted into Fe2O3. The weight of Fe2O3 is determined by weighing the final residue. Weight of empty silica crucible, if it is W1 gram. Weight of empty silica crucible plus Fe2O3 is, if it is W2 gram. Then weight, the mass of Fe2O3 will be W2 minus W1 gram. So mass of Fe2O3 is W2 minus W1 gram. We know the equation, non-balanced equation, how Fe2O3 can be prepared from Fe by oxidation. That means 2 moles of Fe2O3 is got produced by reacting 4 moles of iron. Or if take 1 mole of Fe2O3 will be produced from 2 moles of iron. So molecular weight, if you know the moles, we can it is a molecular weight times of the compound. That is molecular weight of gram of Fe2O3 will be containing 2 into atomic weight, that much gram of Fe. Atomic weight of Fe is 55.85. Molecular weight of Fe2O3 is 159.6. Therefore, 159.6 gram of Fe2O3 will be containing 2 times 55.85 gram of Fe or iron. 1 gram of Fe2O3 will be containing 2 times that of atomic mass of iron divided by molecular mass of Fe2O3. That will be the weight of iron. Okay, but we have W2 minus W1 gram of Fe2O3. That is the our obtained result. Therefore, that much gram of Fe2O3 will be containing 2 into 55.885 divided by 159.6 multiplied by W2 minus W1. So here you need to multiply it by W2 minus W1, that I missed out here. Okay, so this expression, it is multiplied. That means weight of Fe2O3 into 55.5, that is atomic mass of iron, multiplied by 2 divided by molecular mass of iron. So here one correction required. Here you need to multiply it by W2 minus W1. Okay, so the obtained weight of iron, it is for 25 ml or 50 ml of solution that we pipette out from 250 ml stock solution. Therefore, the obtained weight is multiplied by 10 if it is 25 ml is taken. That is, amount of iron will be mass of residue into atomic weight of iron into 2 multiplied by 5 divided by molecular mass of Fe2O3. It is okay. Here again it is reverse case. Okay, so it is multiplied by 10 here if the value taken is 25 ml, and it is multiplied by 5 if the mass is taken, it is the volume of sample taken, it is 50 ml. Okay. Okay. So iron can be estimated by gravimetric method, that what we discussed now. The obtained value we can report. The filtrate the remaining solution which is kept aside for estimation of a nickel or calcium. So how that estimation is done? It can be done using EDTA solution or zinc sulfate solution and EBT indicator. So these are the chemicals which we require for the estimation of nickel or estimation of calcium separately. Okay, here I given a combined explanation is given. The filtrate, it was got prepared with a 25 ml or 50 ml solution taken from 250 ml stock solution, which is again made, it is further diluted, that the obtained filtrate, it is further diluted to 250 ml standard flask made up to the mark with distilled water, then mixed well for uniform concentration. Therefore, the obtained amount of nickel, that is the finally diluted 250 ml here we prepared. In that, we first estimate the amount of nickel or amount of calcium. Then we need to multiply by 10 if initially we take 25 ml for the estimation of iron, that case, or if we have to multiply it by 5 if you are taken 50 ml of solution. That is a normal mathematical calculation. So what we are using is EDTA. EDTA, its full form is ethylene diamine tetraacetic acid. EDTA, ethylene diamine tetraacetic acid, as such it is sparingly soluble in water. Therefore, usually in our lab we use disodium salt of EDTA, which is almost readily soluble in water. But don't forget to add dilute sulfuric acid before adding water. Otherwise, even hydration is possible. There will be a mass difference. Therefore, disodium salt of EDTA, first we need to add sulfuric acid, then it is made up to the mark. The structure of EDTA is given. If you want to simplify it, this expression we cannot, this molecular structure we cannot use to write the chemical reactions all the time. It can be simplified. Whatever reaction takes place, that will happen to the either to the hydrogen center or to the negative charge. Therefore, the entire that structure can be taken as X. Therefore, we can write as Na2H2X, or sometimes we can write as H2X, or simply we use the term EDTA for the reaction. Okay, whatever reaction takes place, it reacts to the this acidic hydrogen, see carboxylic hydrogen, or to the negative coordination bonds are formed at the negative charged carboxyl group. So how to prepare EDTA solution? EDTA solution, if you want to prepare 0.01 normal disodium sulfate EDTA, you need to weigh 3.723 gram in 1 liter standard flask. And it is made up to the mark, shaken well for getting the uniform concentration. How to estimate nickel or calcium? Only a nickel expression is given, nickel or calcium. It has to be treated with a non-excess amount of EDTA. EDTA will react with the nickel form the EDTA nickel complex, or EDTA will react with the calcium ion to form calcium EDTA complex. That is the reaction. Uh, After reacting here, whatever remaining back, so here excess EDTA is added, a known amount. So usually we take a regular, our lab purpose, we take 30 ml, some 25 ml of a solution, we'll treat with 30 ml of EDTA. So that means from the 30 ml, that is excess is there. Some few ml of EDTA only will react with the nickel because it is very diluted solution. So by back titration with zinc sulfate, so that's why you are using zinc sulfate. Back titration with zinc sulfate, as well as to standardize EDTA also, we are using zinc sulfate. So back titration with the zinc sulfate solution with the EBT as indicator, ediochrome black tea as indicator, will give the volume of remaining back after reacting with the nickel 2 plus or calcium 2 plus EDTA. From this remaining back, we can find out how much is reacted. Therefore, a schematic representation is given. A conical flask, we are pipetting out the 25 ml of a nickel solution or calcium solution. That is the filtrate, which is diluted to 250 ml. From that, we are again pipetting 25 ml to a conical flask. So it is represented with the nickel. We need to add EDTA. When you add EDTA, a few EDTA, the initially the EDTA, that is excess EDTA is there. EDTA will react with nickel, forming EDTA nickel complex. So this I representing as a EDTA nickel complex, and EDTA will be remaining back there. Excess is there. So it has to be titrated with that of help of EBT as indicator, because volumetric analysis we need the visible color change to stop the reaction. This is the structural representation of EBT, ediochrome black tea. It can be written as H2Y minus also, because this hydrogen and these two hydrogens are reactive. The other structure will remain as such in product also, and here it is O minus and Na plus. Therefore that negative also taken. Sodium is it will be ionized form if it is in solution state. Therefore we can write as H2, the remaining structure as Y, and a negative charge on that. Or simply we use EBT also to write the chemical reactions. At pH 10, if you maintain pH 10, the indicator EBT, it exists in blue color. So when EBT form a complex with the metal ions at pH 10, say a complex with a nickel ion or calcium ion or zinc, any metal ion, it will be converted into wine red in color. That means if you add a indicator containing a metal ion, then the color will change it to wine red color. Or if a metal ion comes in contact from burette, if you add excess metal ion, and when it comes to contact with the EBT also, it changes color to wine red. How this buffer pH 10 buffer is prepared? It is usually prepared from ammonium hydroxide, ammonium chloride. If small amount of buffer is required, we can weigh 5.2 gram of ammonium chloride into 20 ml we add, or we can take it into a standard 100 ml standard flask. To that 35 ml of 10 molar ammonia is added, remaining water diluted to 100 ml, then mix it thoroughly for uniform concentration. From that we can take 5 ml of buffer solution pH 10. If you want large amount of a buffer, so many titrations, large titrations or a whole batch titration required, then large amount of buffer solution will be prepared, around 17.5 gram of ammonium chloride, 142 ml of ammonia, 250 ml standard flask. It is diluted and made up to the mark, shaken well for uniform concentration. So we want to estimate the whatever EDTA remaining back, or whatever EDTA which is remaining after reaction with nickel, and we added EBT as indicator. Here there are no free metal ions, therefore EBT is set free. Therefore free EBT is having blue color, therefore the solution is blue in color. If you add zinc 2 plus ion from the burette containing zinc sulfate, which is a having non strength, normality is known, actually it is zinc sulfate 7H2O. Initially the zinc 2 plus reacts with the EDTA which is present in the conical flask. Okay, once the EDTA all reacted, it forms a zinc EDTA complex. Then towards the end point, then this the excess zinc, we are adding 1 drop of excess of zinc 2 plus, that will combine with the EBT, forming zinc EBT complex, which is having wine red color. Therefore, from blue color it changes to wine red. That means we added 1 extra drop of zinc 2 plus to identify that EDTA reaction with zinc 2 plus is completed. Okay, so when we get a color change from blue to wine red, we will stop the titration and we take the volumes for the further calculation. Okay, calculation I will explain at the towards the end of this presentation. Prior to the estimation of nickel calcium, we need to standardize the EDTA solution that we prepared, that is disodium salt of EDTA. It is standardized using zinc sulfate solution. Approximately 0.71 gram of zinc sulfate crystal is prepared in 250 ml standard flask. Uh, Remaining water is added, made up to the mark, shaken well for uniform concentration. Conical flask, we pipette 10 ml of the prepared zinc sulfate solution, 5 ml buffer is added, and indicator is also added. So here we have three zinc ions. Zinc ions will combine with EBT, it will be converted into wine red color. Okay, therefore the flask immediately changes to wine red color. From burette, we are adding the standard the disodium salt of EDTA solution, which initially reacts with the remaining free zinc ions present in the conical flask, because only few drops of EBT we added. Only few zinc ions are combined with the EBT. There are remaining a lot of zinc 2 plus ion. So initially when we do the titration, the EDTA, when we add disodium salt of EDTA, we add from burette, it will be reacting with the zinc 2 plus ions. And towards the end point, once the EDTA reaction completes, then it will take out the zinc from zinc EBT complex, which is wine red in color. Therefore this complex will break, that zinc also will be taken by EDTA. So EBT will be set free. So when EBT is set free, it will change back to its normal color, that is blue. Okay, so calculation part, let the weight of zinc sulfate 7H2O is y gram. Okay, you can weigh, we are only preparing the zinc sulfate solution. We know the weight of the zinc sulfate. Molecular weight of zinc sulfate 7H2O is 287.54. Therefore, strength of zinc sulfate 7H2O is weight into 4 divided by 287.54. Why we are multiplying here 4? Because we need to calculate the strength in terms of liter. Okay, normality by definition it is in liter. We have only prepared only 250 ml. Therefore, 250 into 4, that is converted into liter. In conical flask, we are taking the volume of zinc sulfate. We are pipetting 10 ml of zinc sulfate 7H2O. And titration, we'll get the volume of EDTA, let it be ZML. So you need to do 2-3 trials until you get concordant values. Strength of EDTA is calculated as normality into volume of zinc sulfate divided by volume of EDTA, that is N1V1 equal to N2V2. So we will get the strength of EDTA from this expression. Then estimation of a nickel or calcium, its calculation. If conical flask contains 25 ml of nickel or calcium ion, it is mixed with 30 ml EDTA, that is actually excess, then EBT is used as indicator. The titration, we are titrating it with zinc sulfate solution, zinc sulfate 7H2O. Let the titer volume will be as UML. Okay, so you will be getting the titer value after getting the concordant titer value, that is taken as the volume of zinc sulfate. Therefore, volume of EDTA, which is actually the volume of EDTA remaining back after reaction with the nickel ion or calcium ion. Okay, it is separately. If nickel ion contains remaining back after reaction with nickel ion, if it is made up of calcium ions, the solution contains calcium ions remaining back after reaction with calcium ions, that is NV zinc sulfate 7H2O divided by normality of EDTA, that is VML. Okay, let it be VML. Therefore, volume of EDTA which actually reacted in conical flask with the nickel ion or calcium ion will be 30 ml. Initially, we added 30 ml. From that, VML was remaining. Therefore, 30 ml minus V, that much volume of EDTA reacted with our nickel or calcium ion. Therefore, that is the volume of EDTA reacted with, that is 30 minus V ml. Volume of EDTA remaining back or reacted with nickel or calcium. Therefore, strength of nickel 2 plus or calcium 2 plus, strength normality we calculate in terms of a liter, that is NV DDTA divided by volume of nickel or volume of calcium or volume of the filtrate, we say in general. Therefore, amount of nickel 2 plus or calcium 2 plus for the diluted 250 ml. Okay, this is strength calculated for 1 liter, but we prepare only 250 ml. That we diluted, the filtrate is diluted to 250 ml only. Therefore, we need to calculate for that 250 ml. That is, it is divided by 4. Okay, so strength of the solution multiplied by atomic weight of nickel or calcium. Atomic weight of calcium is 40.07. Atomic weight of nickel is 58.69. So you can use, if it is in case of calcium, you have to substitute with 40 here. If it is nickel, then atomic weight of nickel, that is 58.69, you need to substitute. Then finally, what I explained initially, that the obtained amount of nickel value need to be multiplied by 10 if 25 ml of solution is taken for the estimation of iron in that. From that, the remaining filtrate we used, or if you prepared 50 ml from the stock solution to estimate the iron, so then the obtained amount of calcium or nickel, it need to be multiplied by 5. So this is how we can estimate the iron and nickel mixture, or iron and calcium mixture, by gravimetry, and followed by the volumetric or titrimetric method with the EDTA, zinc sulfate, and ABT solutions. So hope you understood the theory part of this experiment. Lab, you can perform it well, and you'll be getting the results, accurate results you'll be getting. So thank you very much for watching my video. Hope you enjoyed it. Have a nice day.